Hello students, this is Sangeetha, Assistant Professor, EC Department, SNS College of Engineering. So today we are going to see about the DSP. So that is Digital Signal Processor. So what is DSP? So it is a specialized type of microprocessor chip designed specifically for processing digital signals such as audio, video, speech or any other type of data that is represented in a discrete form. So DSPs excel at performing mathematical operations and transformations on digitized signal in real time, making them ideal for applications requiring high speed signal processing and computational efficiency. A DSP performs different mathematical functions very quickly like add, subtract, multiply. Let us move on to the basic block diagram of DSP. So here it is microphone, some filters, ADC and DAC are used. So these are the basic components of digital signal processor. The first one is microphone. The microphone captures the sound and converts them into electrical signal. That is it. It acts as a transducer, and next it is given to the signal condition and then filter. In filter, the signal from the microphone may pass through a filter to remove unwanted frequencies or to shape the frequency response according to the specific requirements. And then it is passed to ADC. The analog signal from the microphone or a filter is converted into digital form by the ADC, allowing it to be processed digitally by the DSP, that is digital signal processor. And after ADC it is passed to the digital signal processor. The DSP processes the digital signal using various algorithms such as filtering, equalization, compression, etc. to manipulate or enhance the audio signal. Next to DSP is DAC. After processing by the DSP, the signal is converted back to an analog form by the DAC, and then it is given to the filter. Similar to the first filter, this filter may be used to further shape or refine the audio signal before it is sent to the loudspeaker. And in loudspeaker, it converts the electric signal back to sound waves, which are then heard by the listeners. So this block diagram represents the basic audio processing system where the signal from a microphone is processed digitally using a DSP before being converted back into analog format for playback through a loudspeaker. So filters are included at both the input and output stages for signal conditioning. And the architecture, let us move on to the architecture of DSP. So there are three types of digital signal processor. One is von Neumann architecture, hardware architecture, and super hardware architecture. First we will see von Neumann architecture. So in this architecture, see the block diagram. Here the CPU and memory is shared, that is data and instructions. There is no separate memory for data and instruction. It shares the common bus is shared. So in von Neumann architecture, follows the principles of von Neumann architecture. The von Neumann architecture is a computing model proposed by a mathematician and that is John von Neumann in the mid of 20th century, which forms the basis for most modern computers. It is characterized by the separation of programming and data memory along with the use of single shared bus for data and instruction. So von Neumann architecture means that the DSP processor has a unified memory space for both program and instruction. This contrasts the hardware architecture where separate memory used for both instruction and data. Let us move on to hardware architecture. So hardware architecture, the block diagram shows the difference between the hardware architecture and monument. So the CPU, and there is a separate memory for program and data. So hardware architecture is a computer architecture design that separates the storage and processing of instruction and data into distinct memory spaces. It contrasts with the von-Neumann architecture where program instruction and data share the same memory space. So separate memory spaces for storing instruction and data. This means that instruction and data accessed using different buses, allowing for simultaneous access to the instruction and data so that the speed will be increased. And instruction memory, the processor fetches and executes. It typically contains the program code and it is read only, meaning that instruction cannot be modified during program execution. Data memory stores the data used by the program for processing. This includes variables, constants, and other data structures. Data memory is often read-write, allowing data to be read from and returned to during the program execution. So the parallel access is ensured. The separate instruction and data memories allows for parallel access, meaning that the processor can fetch an instruction from the instruction memory while simultaneously accessing data from the data memory. This can improve the overall system performance, especially in applications with high memory bandwidth requirements. So the hardware processors typically have dedicated units for fetching instructions and accessing data. This specialization can lead to more efficient processing compared to architectures where instruction and data shared same memory space. So the main applications of hardware architecture is commonly used in embedded system, digital signal processor, microcontrollers, and other applications where efficient memory access and processing are critical. So hope this video will help you to know the basic about DSP, the block diagram of DSP, and a different classification of DSP. Thank you.